Hi everyone, Chris Harden here. I'm continuing my video series on a project that I've created called Ollama Game Cards, which is an AI-generated print and play game card maker. And I've got a couple of videos already that talk about the application and how to generate images on the back. This one is going to be focused on the workflows and some of the challenges that I had in using llama 3.1, the 7 billion parameter model from Meta, as well as some workflow efforts with different tools like Claude and Gemini, etc. So this is more for the machine learning folks who want to get in and see how to potentially use the tools. So before I start, you can actually download this and try it out yourself. It's all free and open source if you want to sync it down. There's a README, etc. Okay, so the first thing I'll say is I got inspired to do this with a blog post that came out, I guess it was a couple of months ago now, a month and a half roughly, where the Ollama group showed how you could do function calling from a large language model, in this case llama 3.1. So this is little ollama.com blog/tool support, and you can see that this was pretty exciting stuff that llama 3.1 had introduced tool calling. So I started out building the Ollama game card generator with this in mind. I used a function call, and I essentially was trying to run all of the game card generation from llama 3.1. So in this diagram, if you can imagine an arrow coming down from llama 3.1 through that function call, and it was going to generate the cards, generate the backs, and all of this stuff. Because I was excited, I thought, okay, I can just give it a tool, tell it what I want, and it would call all the functions. And I worked that way for a few days as I got the infrastructure in place. I kept struggling because I didn't understand that llama 3.1 was not going to give me all of my questions in that case, or answers, or questions and answers through this function call. It kept limiting the number of entries it would give me. So if I asked for 50 questions, it would give 8. And what I began to realize is that the function call here was not really intended to be the output of the system, at least for my use case. Instead, it seemed like the function calling was more around augmenting what the model could do. In this case, the most popular case that I've seen so far is, the models stop training at some version, and then they need to go out and search the internet. And so there's function calls for going out to the internet and getting information or live data. This sample from the Ollama group happened to be around weather. So it's a little bit of a smaller API experience, at least is what I saw. And so once I understood that limitation, I also realized I didn't need to make the model call my API. I could just call it, get the information, and send that stuff over to my API. Now that being said, okay, then what would you want to use this for besides what I just described? Well, I have an idea. I actually might make an application that uses llama 3.1 to pull all of my email down. Because you may remember, you may not know, but llama 3.1 can be run locally if you have a decent GPU on your computer. And I've always wanted to make something that will go look through my email and delete all of the spam that I get, because I have some pretty old email addresses and they get a lot of spam. And I don't necessarily use Gmail for that. I have my own domains. So I might go in and build a set of function calls. You can do multiples, by the way. It's not just one. You can just have multiple functions here and say, okay, get the next email. You figure out whether or not it's a junk mail, and if so, delete it. And that could be like 2 or 3 of those in here that would build out. But that's in the future. So for now, that was a lesson learned. If you're trying to figure out how to use function calls, think in terms of a smaller, what can I do something small or to give it fresh data, not necessarily handing off the keys to entire application and having llama 3.1 run it. Again, that's my experience. We'll see if you have some different experience when you watch the video. Okay, so the next phase of this application is to talk with you about some of the challenges that I had with llama 3.1. So I'm going to go over here to the coding interface, and I'm looking at my main Python. This is Python scripting. And so one of the big challenges that's often comes up is, how do you get the model to give you exactly what you want? And I struggled with this for a while. I'm kind of new to how to prompt large language models just to give me exactly what I need. But I'll give you the basics right here, and you can kind of use this for your own learning. The first thing you do is you can give it a system prompt, the role of what it is, and then what it is, and then also the user prompt. And so using these three pieces of the same message, you pass it all at once, you can get the model to give you exactly what you need, or increase the likelihood of getting exactly what you need. And so after a while, with the three types of cards that I currently generate, which is a word list, a question list, and a question and answer list, I came up with these types of outputs, which is what kind of list you want. Don't do any numbers, for example. No yapping is a common way to make sure that it doesn't give you all the other stuff like, certainly, here's everything you need to know about your list, and all the kind of annoying stuff that you don't want. You want an exact API. And you come and you reinforce the output format in each version. So when you run the application, this is all being passed in the background to the Ollama, through the Ollama interface to llama 3.1. And here's one with just questions. You can also give examples. So I gave it an example list here. Example, this is a question, question mark. Is this a question, question mark, etc. And then the most complicated one was having it give me a list of questions and answers that I could then parse later. I tried using the JSON output that it gave, but even the JSON output was a real struggle to be consistent. There's also, you could use instruct versions of the models, which I haven't had a chance to try yet. This is just the base 3.1 model. So take it for what it is. You can go in and change the model type with this code if you want to, and try a different set of versioning. But what I did was I kept the prompt as well as how I treat the string that it sends back outside of the rest of the code, so that if I add another model, I can go in and then change how I prompt it and change how I handle the string once the model comes back to me. So say if you're wanting to use something like Mistral, then Mistral is going to come up with a different response. How do you handle that? So anyway, this is how I build the prompt up, and I send all three. And the interesting part too was that you can get ahead of some of the junk that it wants to spit out by telling it the role. It's an assistant, and say, okay, in case it always loved to say here's the list, I put that in there so it doesn't need to repeat it, and that keeps the output clean. Once you get the response, then there's cleaning to do. So see, here's the actual call right here to Ollama's interface, and here's the model reference, llama 3.1. It's a lot like what you would do if you were on the command prompt. What you're looking at here is I've actually loaded llama 3.1 with Ollama. So I could talk to llama 3.1 right here and see the kind of response that I would get. But in the API, you do it this way. And so here's the challenge. All of this thing you see here, response content is equal to response, blah, 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 blah. I am cleaning out all of the bizarro, random, inconsistent string management with different carriage returns. A backslash is a carriage return. Spacing at the front of the line, etc. that llama 3 gives me, and as I said earlier, quite inconsistently. So you have to do a lot of string management to get exactly what you want out. As I said earlier, I did go down the JSON path, for those of you who are familiar with the fact that these will also send JSON, but it's not real consistent, and that's the challenge. So I finally landed just on a basic unnumbered list that had a bunch of carriage returns. And doing this, 9 times out of 10, I actually get a list that it can run, and I can do a good job with feeding it consistently to my my card generator. Anyway, so here's all the prep for the rest of the card generation. But this is the interesting part here, is when you're dealing with these large language models, how do you make sure it doesn't just give you trash every time? Also, in order to just minimize having to do things over and over again, this particular implementation, I have the ability just to send a couple of arrays of strings to it, or if I want to surpass like the llama interface, because sometimes I just want to make sure the PDF generation was right, I have a couple of string arrays that I have here just for testing, and you can add your own QA tests in there if you want to, and it basically helps you to ensure you can smoke test or in a way unit test your own code for PDF development if you want to go and make a new template without always having to talk to Llama. And there's instructions in the README file on how to use these test arrays. Anyhow, so that is some of the challenges with using a model like llama 3.1. Now let's talk about the work interface. I started out just using a collection or back and forth between ChatGPT, Gemini, and Claude. And I also was talking to Llama directly. So this command line interface, this is running Llama 3 on my own computer right here. This is all local. So as I was trying to figure out how to craft this application, the first thing I did was I went to ChatGPT and Claude, which are my two favorites, and I'd go into Gemini every now and then as well. There's a big distinction right now with what you can get from Claude and from ChatGPT. ChatGPT is that interface. It will do a great job of generating code for you and explain what's going on, which is great. So this is how I started out. I actually wanted to be sure I used the AI generative tools as much as possible. So everything that you see was coded by them, and then I had to do some debug work, of course. The interesting part, though, is that what Claude has been a real game changer. And what a lot of people don't know is that Gemini also has it, but it's not quite as intuitively obvious as to where to go. I believe that this is also true for Copilot inside something like a Visual Studio. Copilot is the one from Microsoft. I just don't pay for that one, so I don't have it added. But what happens is you go in here, and I've done other videos on this. It's getting really common to see these. You go in and you tell it what to do, and it'll generate the code. You can also attach up to 5 files at a time, like I did here, and ask it for information, or ask it to generate a new file, ask it to make changes, and it'll go through every single file, and it'll update it. So here's update config editor, update mainpy, updated, in this case, on any file. It does any files, it does JSON files. So you can work with it, and if you continue to work in the same context, it's going to remember all the other files you uploaded historically. So I've kind of settled in really on using Claude, and instead of just using the free version, which you can do and get this workflow, I did start paying for it about a week and a half ago because I just felt like it was really worth the money. And so it's not too expensive as long as you are getting good value from it. And then you come down here and you just download the file. And so my workflow would be to download these files, and then either inside of VS Code or whatever your environment is these days, you'd get the new file. I'd do a diff between that one and the other one. You could just right click and you could compare them. You could also do a comparison with Git GUI itself. Let's say if you downloaded an updated version. Oh, I just downloaded an updated version. Let me give you an idea of what this means. So let's go with here, updated generate cardbacks PDF PI. I'm going to download this one. It's a little stale now, but the workflow I was using was I'd get this one. I'd go into the download directory because it'll just download it there. And let me cut it, and I'll move it over to my source directory and just toss it in here for now. And so this is the generate cardbacks PDF. So go like that. Now I happen to love Beyond Compare, but instead of using Beyond Compare, I'm going to actually use Git's diff tool if it'll let me. Well, okay, let me do it this way. So say Git show more options, and where's the Git GUI? Git GUI, and it can show the differences here. I used this when I was actually changing the files. Actually, let me just do it this way because I like this more. Beyond Compare is a great product, and I'm not paying for it yet on this particular computer. But I would diff those, and then I'd right-click and say move this over there, back, copy left, copy right, and just keep the stuff I wanted. Because Claude is trying to save you a little money, it doesn't output every single piece, or it will outload just a bit and say, hey, go in and just change these sections, or it's just also trying to focus you in. So let me also show you what it looks like inside the editor. If you're using VS Code, you can do this as well. So cardbacks PDF right here. There, and you can compare them this way. So same kind of diff tool, not as great an experience because the screen real estate is kind of hefty, but still. And that's the workflow. Then you save it over and run it again. And then of course you delete the file. Now, that's pretty good, especially if you're trying to use an online tool like Claude. What many people don't know is that if you are also using Colab notebooks or Jupyter notebooks, which is also great for Python, Gemini is built in here on the side. And I did a video on that a while back, where if you're coding over here, Gemini's sitting right here. It'll look at your errors and automatically generate a suggestion for you. It'll edit your code for you. So Gemini is built in really nicely into Google's Colab framework, which is the same experience as you have here in Claude. I haven't, again, got one in a particular editor, but I'm assuming Colab is like that. I've also found some write-ups that you can use a plugin for Visual Studio or VS Code that will allow you to bring Ollama 3.1 into this environment. I just haven't tried that yet. So that is a workflow improvement. But if you haven't looked at Claude or you haven't looked at Google Colab notebooks, it's a great way to do some Python work as well. But that's essentially how your workflow goes. Now, here's a really cool thing before I'm done. I also wanted to use this for generating my README file, my diagram as well. And so this is what I did. Let me go and my requirements file and a EULA file. So all of the stuff that I have here, let me go back to the main root at the top. I used Claude to generate the README file. And then I made some changes. The EULA, as well as the requirements list. And it just kind of worked almost out of the box. I would say 90%. It got me there, 90%. So for example, let's go over here and see if I can find it. It's got to be right at the bottom. Here's my README. Okay, so it started off, it's this rest of README. This is a good example where it didn't include it when I iterated, but I didn't know how to include an image. So I said, hey, can you add an image? Let me go a little higher. README, here we go. So here's my instruction. Create a README MD to teach new users how to set the project up, run it via the GUI, run it via the batch file with the inis, and test parameters. It spat out all of this, which was super cool. And then I went back and iterated. I changed it to my Git repo so that you know where to get it from, and added a few things. It actually also even did a best practice talking about installing, either v-environment for Python so you keep all your stuff the same. I happen to use Anaconda. And check this out. I wasn't quite sure if it would do diagrams. Are you able to generate diagrams from the code modules? Well, certainly. And it generated the mermaid diagram that you see over here. And of course, GitHub has mermaid built in. It'll read it. But what the cool part is they've integrated that right into the tool as well. There's what the diagram looked like when I first generated it. And you just download that mermaid file, put it into your GitHub, and bam, you've got yourself a diagram. Okay? And then last but not least, as I went through this, I was like, hey, when I'm about to publish this, I really need a EULA. I said, okay, generate a EULA with a completely open Apache license that ensures I'm not held accountable for any damages in the use of the software. Bang, right there. So it went in, generated basically an Apache 2.0 license, which is what I was hoping it would do. That's perfect. And I have included all of that right there in my tree. So keep that in mind. It's not just for code gen. You can also do diagrams. You can do READMEs. You can do licensing. Obviously, you need to look over everything and make sure it meets your needs. But man, it really gets you close. The one thing I'd say is this diagram here, this image that I made here. These are screen caps that I used, and I built this in Illustrator. So that's one thing that it really can't do well, is give you that kind of stuff. But man, does it get you out of the box so much closer? It absolutely does. And so you can look at this as an example of how to do almost all this, actually all this on your own, just with the help of a few LLMs and diffusion models. All right, I'll leave it there. Thanks for your time. If you have any questions or comments, let me know. I'd love to hear your feedback. Love to hear your ideas.